Welcome to further mathematics class. In this class, I will be taking you through sequences and series. The lesson outline include sequences, linear sequence, exponential sequence, series, finding the sum of series. We proceed to definitions. Any set of numbers generated in accordance with a definite pattern constitutes a sequence. Every member of each set is called a term. Linear sequence. Linear sequence is also known as arithmetical progression. The difference between a term and the term immediately preceding it is always a constant. This constant is called the common difference and it is designated by the letter D. Example 1. Find the common difference in the sequence 7, 11, 15, and 19. Solution. The common difference D is equal to the second term minus first term and is also equal to third term minus second term. Therefore, D is equal to 11 minus 7, 15 minus 11, 19 minus 15, which is equal to 4. The nth term of a linear sequence. Let the linear sequence have a first term A, common difference D, and the nth term is T subscript n is equal to A plus n minus 1 D. When n is equal to 1, T1 is equal to A, common difference T2 minus T1 is equal to D, T2 is equal to what? T1 plus D, and that gives us A plus D. Example 2. Find the 40th term of the linear sequence 6, 11, 16, and 21. Solution. The first term A is equal to 6, common difference D is equal to 5, and n is equal to 40. Nth term of a linear sequence is equal to A plus n minus 1 D. Then T subscript 40 is equal to 6 plus 40 minus 1 times 5. And to solve further, T subscript 40 is equal to 6 plus 39 times 5, which is 6 plus 195, and that gives us 201. Example 3. If 8, x, y, z, and 20 are in arithmetical progression, find the value of x, y, and z. Solution. T1 is the first term and that is 8. T5 is the fifth term and that is A plus 4D, which is equal to 20. By solving both equations simultaneously, you have D to be equal to 3. X, y, and z are the second, third, and fourth term respectively, and the answer gives us 11, 14, and 17. Exponential sequence. In an exponential sequence, the ratio of a term and that immediately preceding it is always a constant. This constant is called the common ratio. If T subscript n is the nth term of an exponential sequence, then the common ratio designated R can be written as R is equal to T subscript n divided by T subscript n minus 1. Example 4. Find the common ratio in the exponential sequence 6, 12, 24, and 48. Solution. Common ratio R is equal to the second term divided by the first term and is also equal to third term divided by the second term. R, that is the common ratio, is equal to 12 divided by 6 is equal to 12 divided by 12 is equal to 48 divided by 24. Therefore, the common ratio R is equal to 2. The nth term of an exponential sequence. The nth term of an exponential sequence whose first term is a and common ratio r is given by the formula t subscript n is equal to a r raised to power n minus 1. If t subscript n is the nth term of the sequence, then t subscript 1 is equal to ar raised to power 1 minus 1, which is ar raised to power 0, and that gives us a times 1, which is a. Any number raised to power 0 is 1. T2 is equal to ar, T3 is equal to ar squared, T4 is equal to ar cubed, where r is T2 over T1. Example 5. The second term of an exponential sequence is 35 and the fourth term is 875. Find the first term and the fifth term. Solution. The nth term of an exponential sequence is equal to ar raised to power n minus 1. The second term is ar, which is 35. The fourth term is ar cubed, which is 875. Dividing T2 by T4, we get r squared is equal to 25. The square root of 25 is equal to 5. To calculate the first term and the fifth term, recall that the common ratio r is equal to 5. Making a the subject of the formula, you have 35 divided by r, which is 35 over 5, and that gives us 7. The second part of the question is to calculate the fifth term. The fifth term is equal to ar raised to power 4. By substituting the value of a and r into that formula, we have 4,375. r is equal to 5, a is equal to 7, and the fifth term is equal to 4,375. Series. A series is a partial sum of a sequence. If T1, T2, T3, and T4 are the terms of a sequence, then S subscript n is equal to T1 plus T2 plus T3 plus T4 till infinity. Example 6. The sum of the first three terms of an arithmetical progression is 21. If the difference between the third term and the first term is 4, find the sum of the next 4 terms of the sequence. Solution. The sum of these 3 terms are T1 plus T2 plus T3, which is 21. The common difference is equal to D. The first term is equal to A. The third term is equal to A plus 2D. The difference between the two is T3 minus T1, and that gives us A plus 2D minus A, which is 2D. Recall that the difference between them is 4. Therefore, 2D is equal to 4, D is equal to 2. Don't forget that we are looking for the first 3 terms. So the first term is A. The second term, T2, is A plus D. But when D is equal to 2, A plus D is equal to A plus 2, which is the second term. The third term is equal to A plus 2D, which is also A plus 4. Recall that the sum is equal to T1 plus T2 plus T3. Sum is equal to A plus 2 plus A plus 4, which gives us 3A plus 6, and the sum is 21. Solving this equation linearly, we have 3A is equal to 15. Making A the subject of the formula, you have A is equal to 5. Let's consider the other part of the question. Find the sum of the next 4 terms of the sequence. Let S be the sum of the next four terms of the sequence. Then S is equal to the fourth term plus the fifth term plus the sixth term plus the seventh term. The first term is equal to A plus 3D. The fifth term is equal to A plus 4D. The sixth term is equal to A plus 5D. And the seventh term is equal to A plus 6D, which give us 11, 13, 15, and 17 respectively. The sum total of all of them is equal to 11 plus 13 plus 15 plus 17, which is equal to 56. The sum of the nth term of an arithmetical progression. The sum of the nth term of an arithmetical progression, also known as AP, is given as S subscript n is equal to n over 2, bracket open 2a plus n minus 1d, bracket closed. Example 7. Find the sum of the 20th term of the linear sequence 1, 5, 9, and 13. Solution. The first term A is equal to 1. D is a common difference, and that is the second term minus the first term, which is 5 minus 1, and that gives us 4. N is equal to 20. The sum of the nth term of a linear sequence is given, and by substituting the value of A, D, and N into that formula, we have 780. Sum of the nth term of a geometrical progression. The sum of the nth term of a geometrical progression is given as these two formulas. And the first formula, the magnitude of r is less than 1. The magnitude of r is greater than 1 in the second formula, where the magnitude of r is the magnitude of the common ratio. The sum of the nth term as n approaches infinity is called the sum to infinity of a series and is designated by S subscript infinity. Thus, S subscript infinity is equal to A over 1 minus r. Example 8. Find the sum of the first systems of the exponential sequence 18, 6, and 2. Solution. The first term A is equal to 18. Common ratio r is equal to minus 3. The magnitude of r is less than 1. And n is equal to 6. The sum to infinity of an exponential sequence is given below. And by substituting the value of n, first term A, and common ratio r perfectly into that formula, we have 728 all over 27. Example 9. Find the sum to infinity of the sequence 1, 1 over 4, 1 over 16, and 1 over 64. Solution. The first term A is equal to 1. The common ratio r is equal to the second term divided by the first term, which is 1 over 4, while the magnitude of r is less than 1. S subscript infinity is equal to A over 1 minus r. And when we substitute these values to the formula, we have 4 over 3. Thank you for listening. See you next class.